All right, this video is about transformations of functions, and they're pretty key to things we're going to be learning this year. So some just general principles. Things that happen inside the function are affecting the x values. And things that happen inside the function that are affecting the x, those things are going to move the graph horizontally. In order to get those functions, you're going to be replacing x inside the function with something else. And let's compare that to things that are done outside the function. Things that are done outside the function are things that are going to affect the y values. As is expected, those things are going to move the graph vertically. These are things that are done that affect f of x, affect the function itself. Okay, so the things that are done inside the function where you're replacing x, something is done to x on the inside versus something that's done to f of x, the function on the outside. One of them affects the x on the inside, the other affects the y. Just a general principle to keep in mind. When you're adding and subtracting to the function, those are translations or shifts. When you're multiplying and dividing, those are stretches or dilations. And whenever we have negatives, multiplying by negative, a negative in front or inside, negatives are reflections. Okay, so again, if you keep those general principles, you see you're adding something to the function, you know, oh, it's a shift. So those general principles will help you know how the function is being transformed. All right, so why don't you go ahead and put those at the top of your paper there for notes, and why don't you go ahead and take the rest of your paper and make a little chart. I'm going to tell you about some of the different transformations and how they affect the equation and graph and give you an example. So think ahead. We have 5 topics to go through here. All right, first let's talk about horizontal shifts. A horizontal shift takes the function f of x, and inside the function we're going to either add something to x inside or we could subtract. So what it's doing is it's replacing x inside the function with x plus something or minus something, minus c. Change to the graph. So what this is going to do is it's going to move the graph, it's going to shift it to either the left or to the right. When things are happening inside the function like this, it moves in the opposite direction than what you would expect. So when you see this one that moves plus c, it moves it to the left. And when you see minus c, it actually moves it to the right. So it moves it in the opposite direction of c. Okay, so let's look at an example on what I mean by that. We have y equals x squared. Okay, so we're going to replace the x with x plus 5, for example. Notice that I need those parentheses, right, to keep the 5 inside there with the x. This is x plus 5 squared, so that if we were multiplying this out, we would do x plus 5 times x plus 5 and FOIL, right? So it's either going to be like this, x plus 5, or we'll have x minus 5. If we have x plus 5, it actually moves it, instead of in the positive direction, it actually moves the parabola over in a negative direction. Okay, so here's our parabola, and it's been shifted over to negative 5. Remember that the parabola originally looks like this, okay? And it's been moved from there over negative 5. And then having this negative 5 in here moves the parabola over in the other direction. It moves it over positive 5. Now what about vertical shift? Vertical shift happens on the outside of the function. Either you're going to have f of x plus c, or you have f of x minus c. C is added or subtracted to f of x. What that's going to do is it's going to raise or lower the graph. Because it's happening on the outside of the function, it affects the y, and y moves it up or down. And it's going to happen exactly as you would expect. Plus 5 is going to move it up 5 in the y direction, and minus 5 is going to move it down 5 in the y direction. Horizontal stretch and compress happens inside the graph. Horizontal is the x, and the x value is inside, so this is going to be either f of c times x or f of 1 over c times x. In this case, c has to be a number that's greater than 1. And this needs to be a fraction. 1 over c needs to be somewhere between 0 and 1. So it could be any fraction or decimal between 0 and 1. Remember that when we're talking about x inside the function, it happens opposite than what you would expect. So when we have c times x, that is a compression. And multiplying x by 1 over c is a stretch. So let's look at an example of this. Let's replace x with 5x. Notice that I need the parentheses because the 5 is also squared. The x is squared and the 5 is squared, and that's what the parentheses are doing. Or I could have y equals 1/5 x squared. Okay, so now, if we're multiplying by 5 like that, it's a compression. So the graph becomes thinner. How much skinnier is this than the original one? At 1, how high up is the graph? At 1, the graph is actually all the way up to 25. All right, let's look at the stretch. Okay, it's gonna get fatter. How much fatter is this as a comparison? Where is this point at when we get to 1? Well, at 1, it's only come up to 1/5. Okay, so that point is 1, 1/5 right there. So now let's look at vertical stretch compression. Vertical stretch compression happens outside the graph. Now we have c times f of x, or we have 1 over c times f of x. Again, same thing. The c needs to be greater than 1 at this one, and I'm looking at c to be a fraction on this one. Okay, now the vertical stretch compression is exactly as you would expect, multiplying c by f of x. That's the stretch. And the fraction is the one that compresses it or makes it smaller. Let's look at what we mean by that. On the first one, we were stretching the horizontal. Our original one, this is going to stretch the horizontal out, isn't it? And that's why it looks fatter, right? Because it used to be up here and it stretched wider. Now what we're stretching is not the horizontal. We're going to stretch the vertical. So now we take our same original u, but instead of stretching it horizontally, which is going to make it wider, we're going to stretch it vertically. And when we stretch it vertically, it's going to become narrower. So it's going to go up, and when we stretch it, it's going to be like this. All right, so both of these look narrower, but one is a compression and one is a stretch. This one is a stretch because we're stretching it this way. It got taller. So how much taller? Let's compare it to that one. When we're over at 1, we only come up to 5. All right, now let's look at compress. Okay, so now a compression in the y direction is going to smush it it's going to smush it down, so that it ended up looking fatter. At 1, it's only up to 1 1/5. This one stretches all the way out to 1 over 25. So this is actually wider than this one. Great. All right, and the last type is reflection. So now, when we have reflections, it's going to change the equation by either putting a negative on the outside of the equation, negative f of x, or a negative inside the equation, f of negative x. Either way, whenever we're talking about reflection, it's going to multiply the equation by a negative. When we have a negative on the outside of the equation, outside is like the y value, that's going to be a reflection over the y. If we have a negative inside the equation, if an x has been replaced with a negative, then we have a reflection over the x. Okay, so looking at our example, either we're going to have negative x squared or y equals negative x quantity squared. Okay, so if we have a negative on the outside, that's going to be a reflection over the y-axis. Now this is hard to see because the parabola is actually symmetrical on the y-axis. So that's like you're taking one side of the parabola and you're reflecting it to the other side of the parabola where it's exactly the same. And if we have a negative inside the function, it's going to take our parabola that was up and it's going to reflect it down. All right, great. And those are all of our transformations.